EDGE-Power, robust and secure edge electronics for industrial processes and critical infrastructures. Digital technology is transforming industry. With millions of sensors and massive data, there's an increasing demand for energy, mostly needed for communication and computation. But where does this energy come from, and how can data and energy be managed efficient, secure, and sustainable? The major renewable energy resources like wind, biogas, and solar systems can power up tomorrow's edge technologies. Edge Power shows how renewable energy and smart electronics can work together for secure, efficient, and sustainable edge computing. The core inventions are three new hardware modules, efficient AI algorithm, and an energy protocol. Hansa Tech Solutions developed the heart of the edge power system, the so-called energy module, where all the energy flow and data converge. The edge and process gateways developed by NXP and Torsys simplify edge computing and combine data fusion with local processing and distribute energy and computing power by demand. In real-life demonstrations, for example in biogas plants, wastewater treatment and energy-intensive camera monitoring with AI, the edge power system is put to test. But let's have a look on the work of each of the strong partners from research to industry and let them introduce themselves.
The energy module developed and manufactured by Hansa is the edge power component that controls the energy flow to the other components of the system. It provides two inputs for power supplies like renewable energy sources or batteries, and 6 independent outputs for the power-consuming components. The user can switch the in and outputs on and off, as well as retrieve information about the present energy consumption. This can be done via several interfaces like Ethernet or RS-485, using either the OPC-UA standard or proprietary energy protocol, which are both supported by provided firmware. We equip the circuit board inside the energy module with different components for switching energy flows on and off, converting voltages, and measuring current and voltage at several points. The components are controlled by a microprocessor on a module provided by Car Electronics and integrated into our board. We manufacture the circuit boards on our automated SMD line, which is common practice in modern electronics manufacturing. On an automated SMD line, tiny electronic components are precisely placed on the board by high-speed pick-and-place machines. The process begins with solder paste printing, followed by automated placement of resistors, capacitors, and integrated circuits. Finally, the boards pass through a reflow oven, where the solder is melted and permanently connects each component. This highly efficient production method ensures consistent quality and results in compact circuit boards. We could therefore keep the size of the energy module small, so that the module can easily be integrated into the various edge power systems by our project partners.
Hi, I'm Felix from NXP. And as a company, we are proud to contribute to the net zero transformation, advancing energy systems that are sustainable, reliable, autonomous, and safe. And in the EDGE-Power project, we teamed up with our partners in order to demonstrate industrial monitoring that is designed to minimize CO2 emissions, where local data edge processing plays a key role to optimize system efficiency as well as to reduce dependency from the cloud. From NXP's side, our contributions in the project span several key areas. First thing is bringing in performant yet energy efficient edge computing technology with integrated AI acceleration, such as, for example, the IMX-ADAM Plus, to enable local and fast execution of algorithms for data processing and data fusion. Second thing is the development of the Edge Gateway for the system demonstrator, which is a functional proof of concept that forms the bridge between the local data edge processing and the cloud and forwards only the relevant insights. We contributed to interoperability across industrial environments by encouraging the use of OPC UA and industrial Ethernet. And we brought in our security expertise, enabling secure and encrypted communication, leveraging certificate-based authentication, as well as separating the local and remote cloud segments. And finally, there's the energy management, where our Edge Gateway supports in orchestrating the energy flows and the consumptions. We're proud to be part of the EDGE-Power project together with our partners. Together, we're advancing the next generation of critical energy infrastructure.
Since our founding in 1997, we've been delivering hardware and software solutions for industrial communication and automation, including field buses like Profinet and CAN, and open interfaces like OPC UA and FDT. In the BMBF-funded EDGE-Power project, we've developed robust and secure edge electronics for industrial processes and critical infrastructures under the Octopus initiative. Our goal: to create a technological foundation for energy autonomous edge computing in decentralized systems. Our unique features include AI-powered edge computing for mass data analysis, such as image, acoustic, vibration, and spectrometer data, high energy efficiency through smart management and energy harvesting, and secure data transmission without cloud dependency, serving energy, water, and chemical sectors. In our role, we developed scalable system concepts for the process gateway. The process starts with requirements analysis and system design, followed by schematic creation for performance scalable processors. We design board layouts, assemble components, and perform reflow soldering. The result, a modular prototype with broadband interfaces for sensor fusion and distributed computing. On the software side, we built the board support package for stable integration. Our application software includes embedded image processing, OPC UA communication for secure networking, and security features. We also implemented energy management, including a Energy Data Protocol (EPS) protocol for efficient energy usage. The process gateway optimizes processes in chemical and steel industries through predictive maintenance, fingerprint analysis, and distributed computing. It saves energy, boosts efficiency, and supports sustainability with potential for patents, licenses, and new collaborations between SMEs, universities, and R&D institutions. EDGE-Power is bringing us as a SME closer to practical solutions. Contact us for more details, funded by the BMBF under the Octopus initiative.
As part of the EDGE-Power project, Saarland University has been working intensively on the topic of sensor-near data processing using AI algorithms in an industrial environment. In order to achieve optimizations, the challenges of sensor-near data processing must first be identified. 3 key challenges are the focus of sensor-based data processing: latency, computing power, and energy, as the systems need to be so efficient that they can ideally be operated independently. This leads to the requirement for efficient implementation of data processing algorithms on energy-efficient and powerful hardware. Within the area of artificial intelligence in industrial environments, we distinguish between machine learning and deep learning. Machine learning and deep learning have different pros and cons, but the goal is to combine the positive aspects, the interpretable results from machine learning, and the available specialized hardware from deep learning. By representing interpretable ML algorithms in neural networks, we unite classical traceability with modern deep learning performance. One approach to interpretable machine learning is to first extract features from the data, then select relevant features, and finally perform classification or regression. To combine this approach with neural networks, classical algorithms can be translated into network structures. The result is a representation as a deep neural network. At each stage of the network, it remains possible to understand the results based on their physical interpretability. This creates a deep neural network that is not only powerful but also explainable. By measuring the current, the energy requirement can be determined by multiplying the voltage, time, and the area under the current curve. This value can serve as a basis for decision-making, as depending on the application or scenario, the energy required can become the decisive criterion for the choice of implementation and hardware. The results obtained within the EDGE-Power project have demonstrated that energy-efficient and rapid data processing based on reliable and interpretable AI algorithms could be implemented.
The Helmholtz Center Dresden-Rossendorf is researching new ways to improve monitoring and control of biogas plants, enabling a flexibilization of biogas production. Our solution is an AI-supported imaging system developed together with our partners, giving the plant operator better insight into mixing efficiency. Mixing is the largest energy consumer and a key factor for plant efficiency. The flow in such a large fermenter is very complex, since the fluid is composed of different materials. This and the limited accessibility to the fermenter makes it difficult to measure, and therefore efficient mixing is a challenge. We want to give the plant operator further insights into this using evaluated camera recordings of the fermenter surface flow. A camera system is placed in front of the fermenter window. The recordings are evaluated on dedicated hardware and software from our partners, using AI-based image analysis. The results show the relative filling level, the movement of the surface, and the gas bubbles forming in the fermenter, giving plant operators a clearer view of the process.
Please get into contact if you want to know more about the system and how the hardware and the EDGE-Power can support your application.